Hi everyone! I'm really sorry that I couldn't make it to give you this presentation in person, and I'm also sorry that I'm really bad at using computers, so lucky I figured this out. But nevertheless, today I would like to take this time to talk to you about sustainable aquaculture. So, global aquaculture production of finfish, shellfish, and other aquatic animals has reached 76.6 million tons in 2015. Production has been expanding at a rate of 5.9% during 2001 to 2015 due to the rapid growth in world population, decrease in catches from wild fisheries, and the changing consumer preferences. This growth can actually have a negative impact on the environment due to the high potential for damage to the ocean and coastal resources through habitat destruction, waste disposal, exotic species, pathogen invasion, and large fish meal and fish oil requirements that are further depleting the world's fish stocks, so kind of contradicting the purpose of aquaculture. So, in having that said, there's lots of ways really that you could help improve the sustainability of aquaculture, but here are just three main points that I wanted to focus in on through improved fish feeds, so relying less on fish oils and fish meal and more on other things like insect proteins and like farm byproduct proteins and stuff. Better management to lessen the outputs into the environment, and better wastewater management systems. Like in some flow-through systems, I know that water just goes into the building, goes through all the tanks, and then comes straight out and gets dispersed right back into the body of water of which it came from. And obviously we have learned that that's not ideal. So the largest production cost for commercial aquaculture for most carnivorous fish species is the fish feed. In 2006, approximately 25.4 million tons of aquaculture feed was produced. So one of my ways to improve sustainability of aquaculture is integrated multi-trophic aquaculture. So this is a practice that combines the cultivation of a finfish, a shrimp species, with an extractive species, kind of like a shellfish. And then it also incorporates an inorganic extractive species like macroalgae. So this is done to increase farm sustainability and lessen the environmental impact from sea cage rearing. This is really good, and it works well because not only that, but you're also a more diverse farm this way. As you can see in the picture here, it shows a lot, like, you can see your filter feeding mussel along with your carnivorous fish. You got your macroalgae over to the side. So you also have more to market. You can also market your algae. You can market your shellfish. You have more room to grow. So another cool production method that's relatively new. These two aren't done in production yet because the funding is still coming, but hopefully soon. The aquapod is one of them. It's a free-floating, untethered deep ocean fish habitat. It reduces overcrowding and creates less stress on the environment due to its unique ability to change location with the ocean's current, and being in 140 foot of water, the ocean can better absorb the fish waste. The design is environmentally superior to other sea cages as it's made from recycled plastic and it's predator-proof. So while most sea cage sites now, they're made with copper wiring in the netting to prevent from the predators from being able to penetrate the nets, this is still a better option. It's more environmentally friendly. It utilizes more resources by recycling plastics. So another very similar to the aquapod is the sea station. It's placed several kilometers offshore. The idea is similar to the aquapod in that it's open ocean aquaculture to allow the ocean to better absorb the fish waste. The sea station has an underwater feeding system monitored using underwater cameras to avoid the overfeeding issues, which is going to make this a lot more environmentally friendly anyway, because it reduces the outputs into the environment, as well as being more sustainable, using less feed materials, helping to achieve the best food conversion ratio, which is very important, and also that would make it more economically friendly to the fish farmer, as there would be less to buy if you have a better food conversion ratio. So this cage, actually, what's cool about this one is it can actually be controlled to be raised to the surface of the water or sink deeper to avoid the stormy weather. So like when you know a bad storm's coming, you can control the movement of the cage. So this cage is really ideal because it also reduces stress, which embraces animal welfare, and it's also an improved system because increased flow and currents and oxygen availability. These cages were made to last more than 10 years, which makes them highly efficient because you wouldn't need to do much replacing or upkeep. Another cool thing about this that I read was that while the ones in development right now, they're stationary because they're an innovation, like they're new, but they're actually supposed to have propellers on them so that they can actually move them and control them based on a computer to make them go from place to place so that they're not in one area for so long so that they can't make as much impact. So another thing for wastewater management really is a good idea for that would be to use constructed wetlands. I know it was talked about in class for some different uses, but I've read quite many studies actually that show that it can be used in flow-through systems, even recirculation systems where the water gets brought back into the tanks. So constructed wetlands are engineered systems designed and constructed to make use of the naturally occurring processes of a natural wetland involving macrophages, soils, hydrology, and microbes to assist the treatment of wastewater. So this has been proven effective at nutrient removal for aquaculture wastewater treatment, protecting waters from eutrophication, and the potential use of the treated water. So there's no chemicals involved in this. It's a great opportunity to be more environmentally friendly, and also reuse. Like you're gonna reduce your costs because you're not using machines to filtrate your water for you. You'd be using natural resources. So not only that, but your electricity bill is going to go down, and it's going to really help the sustainability aspect because aquaculture really struggles in this aspect. So in conclusion, in order for the aquaculture industry to become sustainable in a way that it contributes to world fish supplies, it must reduce the wild fish inputs in feed and adopt more ecologically sound management. So this is very true because the industry now, it's hard. They won't want you making sea cages because of, well, the obvious. There's the effluents from the fish feeds. There's also the chance of medicated feed being released into the environment, even though a lot of the medications are not the ones that the media makes them out to be. However, that's still an issue. So, but if you want to farm and you go and do a flow through or recirc system, you have so much in electricity bills that you're using so many other non-renewable resources. Is it really the most sustainable method? So I really think that as the world population continues to increase, aquaculture is going to be a very important thing in development, and I think that more attention should be being paid to making it more sustainable. So I thank you for your attention, and I hope you bared with this presentation. Here's my references for the text and then the image references. Okay, thank you.